All right, welcome back to the second video in the new topic for BGP. So we've moved on to a different subcategory. We moved on to the routing policy subcategory. Within that subcategory, we're focusing on the 4-byte ASN topic, or ASN topic, ASN. Where we left off, we went through and kind of understood more about why 4-byte is a topic, and it's a topic because originally most autonomous system numbers for ASN were 2 bytes, but they had to extend it out to 4 bytes because they ran out of autonomous system numbers they could hand out. So we learned about a special syntax you can include, and it's the L letter at the end of your autonomous system number, and how in some cases, such as having it be a route distinguisher or having it be part of a community string, if you don't include that special syntax, it'll reject it, but it will just simply tell you to use it. So kind of valuable to see. It kind of sucks to see your commit rejected for the first time in the middle of an exam. So the fact that we can see that in the lab, I think is going to be really valuable. So where I ended the video last time, I was trying to get this topology to work. It looks like the classic GNS bug happened, where that the best defense is to make a superfluous commit, because it rolls back your last commit randomly. So let's make sure that all of the so all of the routers are named correctly now. You can see their naming is they went counterclockwise when they named it. So I think that's pretty unintuitive. I generally think clockwise is more intuitive than counterclockwise, but that's okay. Not worth a downvote for sure. Yeah, so let's try to get this to work. We were going to do this last time, but there was an issue where it just wasn't quite as easy as I would have hoped, and the video was running long. So so I'm hoping to finish this during this rare early morning video. I'll get about a half an hour to work on this, and hopefully that'll be enough to finish it. So unfortunately, as I said earlier, there is that GNS bug where you need a superfluous commit, or else it'll roll back your most recent commit. So, and in this case, it is basically, yeah, so it looks like it has done that for multiple devices. So I'm going to need to, some of them, the commits were basically superfluous. It was just changing the host name. So that's no big deal. Others were bigger. It was adding whole configuration. Okay, so now the host names are good to go. I'm just going to open this again because I'm kind of suspicious of this. It looks like they opened in order once. They're kind of not consistently opening in the same order. And then they're not all consistently kind of behaving in a way that is predictable. Yeah, that's something that happens. I'm not sure why that happens, but hit your icons in your icon tray often don't close, and that seems to cause issues. I mean, it looks like when I got rid of those icons just by hovering my mouse over them, it behaved a lot more predictably. Unfortunately, it looks like it did roll back my superfluous commit, so I'll just need to change this. All right, and hopefully I can finish this without much difficulty. So let's get started. So configure private, edit interface 000, unit 0, set family INET address 10.0.0.1 because it's an odd number. And we'll need to do .1. And now it's going to be 0, 1, 2, 3 for the networks. And still .1 since it's an odd number. Okay, so now let's do BGP. We're going to have a iBGP and an eBGP connection. So the iBGP is going to be internal, not external. And we'll make the even numbers be passive. All right. Now, of course, we're going. So let's edit the eBGP. All right. So everything looks good here. Let's go ahead and add those static routes because, of course, this is just going to be our patch fix for this particular topology. It's not going to be scalable. It's definitely not a solution you want to implement in production, but just for the purposes of sniffing out those packets that show route loop detection, it'll be perfectly fine to set up simple static routes in order to reach the loop back on the BGP neighbors, because otherwise you'd have to use the port addresses there. All right, and much of this is going to be reusable. Oh, it looks like I also forgot to configure, I did the same thing I did in the last video. It's probably going to cost me some time on the test, so I want to make sure I'm not doing this in future videos. But this is going to go on router 1, or interface 1 is going to go over to router 2. Okay, so yep, and I think a lot of this is going to be similar on the other router, so I will use a notepad. And I hit copy instead of paste, which costs me a lot of time, unfortunately. And right now I have 28 minutes. Okay, so now let's go counterclockwise, just because that's the way the lab is set up. So let's configure router 2 next. So port 0 is going to be going to router 3, port 1 to router 1. So to router 3, we're still going to go clockwise with our ascending network address scheme, 0, 1, 2. So this is an odd number, so it's going to be, or sorry, this is an even number on router 2, so the address it gets is going to be an even number. All right, and then it's getting a .9 for the loopback. And now it's going to have special static routes. It's going to have .3 with a next hop of 0, 1, 2 dot .1 because it's going to an odd, and then this is going to be .10 with the next hop of .1 as well. All right, and now the the global autonomous system number is going to be 1 billion. And now it's only going to have eBGP connections. So the PeerAS statement is going to need to go on the neighbor level. So for that, we're going to just use our system-wide autonomous system and only specify the PeerAS as 12596. But for the and the other thing is we're going to stick to our convention of having the BGP neighborship established from the odd routers. All right, so we need one more neighbor. It's going to be to router 3. And that's going to be, oh shoot, yep, no, that's right, the PeerAS there. So here it's going to have a different PeerAS. It's 60,000. Perfect. Okay, and now it's going to have a different local AS. Perfect. So everything looks good to go here. I can't think of anything I'm missing. So let's paste it in. Oh, and it looks like we've got that issue where it doesn't all paste in. So we'll do it in 2. All right, so commit and quit, perfect. Let's move on to router 3. It's going to be counterclockwise, so it's going to be this router here. But our addressing scheme is going to be clockwise, so the 0 goes here, so 0, 1, 2. So GE000, that's pointing to router 2. So it's going to be pointing to, oh, right, because this is its own address, so it's going to be 2.1, and then it's going to be 1.1 since it's router 3, which is an odd number. So it's going to be 1.3. And then we need a static route to 1.9, the next hop of 2.2, and then to 1.2, the next hop of 1.2. Okay, now this autonomous system is going to be different. It's going to be 60,000. Perfect. Likewise, it's going to have 2 external BGP connections. It's going to have one to 0.9, but the, wait, why is there a, this doesn't look right. It should be to 0.10 on router 2. Yeah, this if we're on router 2, it's got to be connecting up to router 1 and router 3. So this statement is wrong here. Let's delete that. If it will let me, thank you. It won't let me. Oh, I'm not in config mode. Oops, it's got to be pure AS. All right, so everything looks good to go. Okay, so now we're moving on to router 3. And yep, we've got everything much more accurate here. It looks like we would have had the same problem though, because this hasn't been changed to point to router 2. Looks like the pure AS also hasn't been changed. So it's going to point to router 9, yes, but the pure AS is going to be 65,000. It's not going to be passive since it's a odd number router. Then it's going to have a connection to router 2, or sorry, router 4, which ends in .2, of course, because so then they're going to have, I mean, in the real world, you know, it's going to be addressed how it's addressed, so it's not necessarily a bad thing for the router, the lab topology to be numbers that aren't nice and clean to work with, because you'll be seeing that out in production. All right, so, but the pure AS for this is going to be 12596, and we're going to use the global address. So this is all we need. We've got 2 neighbors. We've only got eBGP, and we've got the configuration on the routes with the static routes. So everything looks good. Let's paste it in. Seems to be like I'm making decent time too, which is always good. having to rush through things is not the best way. Okay. Perfect. So now it's time for router 4, which is going to be an even number router. So we're going to have those passive statements. And here we're going to have an iBGP and an eBGP. It's going to mirror the config on router 1 quite a bit. So I'll work off of that instead of the config of router 3. Okay, so 0, that's going to go to, that's going to be 0.2. And then it's going to be 1.2. Okay, so everything hopefully is good to go. Let's make sure all those BGP connections are established. If they are, that's kind of all we need to know. Everything else is going to be all set. So unfortunately, it looks like we've even got one that's idle, which means there's no chance for it to be going into active. So we can ping it. Ping.10, so everything's good there. So our internal, yep, is going to .10. Our external is going to .3. So in the summary, I think we'll get our local so yeah, now we're going to get our local AS. So this goes to 6,000. Oh, we're not going to get our, oh, here we go. Yeah. Unspecified AS 12596. So make sure that those AS numbers are correct. Yeah, this is a iBGP, so everything looks good. Let's see if router 3 is good. And one thing to remember is it does take a little bit of time to establish a BGP connection. Okay, so we've got an eBGP connection going to .2. We've got 12596. So, and here we've got a eBGP connection going to .3 to 60,000. Let's see that 60,000 is local good. 1, 2, yep. So I don't understand maybe there's something wrong with the nope, so that's not true because we've got 168.1.2, so we can ping there. Aha, I think the problem might be that we can't ping from the source address 68.1.3. No, that's not a problem either. So yeah, maybe it's just slow, or maybe there's an error in GNS. But it looks like right now they're both in idle, so they're not even able to attempt to form a connection, which is interesting. Show, you know what? It might be because there's a loop already. So we've got one inactive. That's kind of a better sign than it being an idle. Okay, so why will it not? So we've got a route. There's no issue with it, with connectivity. Let's look at a Wireshark capture that might help things. Maybe I have passive configured on both ends of the link by accident. So nope, I've got no passives here. Okay, so I do have passives here, but it's an even number router, which is what I want. No passives here. It's interesting that I don't have passives here. That is something that I wanted to have. So I think I am going to add those passives in there. All right, so everything looks good to go. Now I got those passives in there. Of course, that's not going to solve the problem, though. It's not going to make it magically come up. But it is what I had initially intended, so. All right, let's sniff the link, and hopefully we can get some insights from there as to why it's not coming up. We will be able to see ICMP traffic over that link. Oh, you know what? So I know what's happening. So, and this is a really good lesson too, because this is something that's been stopping me up a lot. So just to be more familiar with this is really going to help. So I don't have the local address set up. So it's trying to respond back to the interface IP here, which it doesn't have a route for. So I can see if I'm on. So if I try to ping on router 1 10.0.0.2 with a source IP address of 192.168.1.10, that will work, which I guess, yeah, I would have expected that to work. But anyway, let's just try it, and if it works, we'll dive in deeper and figure out why it worked. doesn't work, we can just move on. But let's see, so edit protocols, BGP, group iBGP, set local address 192.168.1.10. And one thing that's neat that we can do to save ourselves some time is just set the local address for the entire BGP protocol, because we're going to use the same local address, whether it's iBGP or eBGP, regardless of the neighbor. So that'll save us some time in configuration. So we don't even need to specify the group. We can just set the local address and it will inherit the local ass. Yeah, I don't know if we got many options for that one. Maybe one cheek over another or something. Let's see here. Okay, so router 3. Oops, it's going to be 1.2 on router 4. So double check the work. Yep, 1.3, 1.9, 1.10. So now hopefully this was the issue. Could take it a while to wake up now. We're getting some in packets from this one. Here we're not even getting any in packets at all. It's just not making it to that device. So I'm pretty sure my wiring scheme, yep, port 1 through there, port 0 there. So figuring these up is going to be port 1. Aha, there we got an open sent. Aha, so we've got the eBGP connection, or sorry, the iBGP connection between router 1 and router 4 is now established. But unfortunately, it looks like that eBGP connection between the two of them still needs some work. Let's see if the eBGP connection between router 2 and router 3 is established. Looks like it's not. We've still got an issue with it being idle. Which is interesting. Oh, you know what's happening? So with iBGP, you can set up the local address, but with eBGP, it doesn't use the local address. I think it automatically changes it. So I think that next hop self policy, you don't need for iBGP. You can use it for you can use it for iBGP, the local address, but for eBGP, you're going to need to use that next hop self policy. Oh, no. It actually says the opposite. So one potential issue with iBGP is that it doesn't change the next hop IP address. So, and the other thing is this isn't for connection. This is for actual advertising of networks. So that's not going to be a factor that prevents it from creating a peer connection. Well, we made it farther. We got the iBGP connection to come up. That's something that I wasn't able to do in the last video. We're just having trouble getting this eBGP connection to come up. I have a feeling it's something to do with there not being a proper policy or something like that. Kind of running out of time here. I don't want to spend too much time on this before work. So let's. I'll come back to this. I'll do 4 videos on this. I'll do the lunch video, the after work video before moving on. As I saw in the last video, the math video, I unfortunately have been spending too much time on particular topics. I would have to study about 4 hours a day in order to devote as much time to every topic as I devoted to the last topic. So that's something that is not going to be possible for me to devote 4 hours a day consistently every day up until the test. I for sure won't be able to do that. 2.5, yeah, maybe. But 4, definitely not. So, okay, so the ICMP works. So it looks like the problem that's happening is we're not getting those SYN packets. They're not even being sent at all. So that's interesting that it's doing that. So I'm wondering if the neighborship statements are correct, but this is the one that's going to be passive, or so that's not going to be passive. So they're only going to be sent from this side. And 192.168.1.9 looks like there's no problems with that. Like 192.168.1.9, yeah, there's no problems with that. So I don't understand why maybe the AS setup on here. Let's see if these numbers match. Come on, let me do the thing. Come on, let me click. Yep, so those numbers match exactly. No problems there. Type external is set up here. Type external is set up here. 12596. Yep. This is 12596. Type external. We've got the local address here is going to be 1.10, 192.168.1.10. Local address 192.168.1.9. So yeah, like yeah, reachability is fine. So there's just some issue where it's not sending out those TCP SYNs. I mean, we can see that it's clearly just sitting dead. It's an idle state. It's not sending out the traffic that I'm expecting it to send out. So show BGP neighbor 2.168.1.9. So maybe we've got some, so peer interface error. This looks interesting here. So let's look up that flag. So this is interesting. Is this meant to be 10 or is it meant to be 9? I don't remember. It is meant to be 10. So why is there a peer interface error? So it obviously has to do with the peer interface. Aha. So, sorry. Aha. Oh my God. So wait. No. See, I thought that the loopback interface was missing, but you can clearly see it's right there. So maybe the static route is different, but it would still, yeah, it would still be able to connect. Yeah, and the static address looks fine. I mean, if there were any issues with that, it just wouldn't work at all. Even the pings wouldn't work. It wouldn't just be the peer interface error that's specific to BGP. I wonder if maybe we just clear it, clear BGP neighbor, because maybe once it gets that error, it doesn't work anymore until you clear it. Kind of like in port security in Cisco, how you have to shut, no shut if it shuts down the port due to a security violation. But it looks like that's not the case. It didn't go back into active. But that's definitely a very good clue as to what the issue could be. This peer interface error, that's going to be, I think, the best clue to help us figure out what's going on. So let's see what we got for here. So, yep, we got peer interface error as well. So Juniper BGP peer interface error. What if I do like a help topic? Or what is it? Help appropriate? Aha, here we go. Oh, nothing matches. What about a help reference? Nope. Here we go. BGP error messages. Maybe this will be here. Peer interface. Nope, nothing here. So kind of sucks that you can get a, yeah, here we go. Must include. Yeah, so I wonder why it's saying that there's a peer interface error. So here it says they solved it. But this is the only time peer interface error actually shows up. So it looks like you have only one peer is up, received. This subnet is not showing in your output. Show route protocol, BGP. I'll try that. wonder if I need a default route, like it's not able to oh, you know what? So I do see something that looks kind of interesting. Here it says it gives more information about my local. Oh, no, 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 but I've got my local here. So do I have my local here? I do, I have my local there. So why does it? Yeah, I don't understand why. So unfortunately, I'm going to have to leave it there. If anyone can help me out, knows what's going on, let me know in the comments, please. I think the best clue you've got to work with is this peer interface error. I don't know why it would have that though, because you can see there are no problems pinging that interface. This is one thing I actually have a guy I work with who has taken this exam twice. So I think I'm going to send that to him today at work, see what he thinks about that, and hopefully I will have an answer about that during lunchtime video. So stay tuned. Thanks for watching.